you should be seeing on your screen this list that talks about dividing polynomials using something called synthetic division. And that's what we're going to be really working with the next couple of days. And it's a shortcut on the long division because the long division is, well, long. It's just kind of how it goes. So I'm going to show you kind of a shortcut method that we can use a lot of times, not necessarily every time instead of long division. And we'll talk more specifically about when we might want to use long division versus when we might use this shortcut method called synthetic division. And that'll be mostly what we focus on Thursday. So what we're going to be doing is looking at this in a different way for our division. So we're going to start out by making sure our polynomial is in standard form. Super duper duper important that we're in standard form. So biggest to smallest in our exponents. And instead of writing what we're dividing by down as our whole root, or like as our whole factor here, like the x minus a thing, like x minus 7 or x plus 2, we're only going to take that solution. So back when we would do our solving quadratic step, which we did last semester, and we would take our factors and set them equal to 0 to find that root, find that solution, find that 0, it's exactly what we're going to do. So we're going to use our root. So this is our factor. But when we do that x minus a equal to 0 to get that x equals a, like that thing, this is our root, and that's what we're going to use. Our root, our solution, our 0, our x-intercept. Remember, all those things mean the same thing. So we're going to use that in setting up our synthetic division. So this list kind of talks you through it. Again, I'm going to have this list as a printout for you guys to glue into your notebook. It'll be like a quarter page. So like if you want to leave yourself a space for that, if you want to glue it in after what we do today. But we're going to do a couple of practice synthetic divisions today, and then we'll practice more with them together tomorrow. So this list just kind of gives you a walkthrough of what we're going to do. But I'm also going to have it up on the page while we talk about the next one, just so that we can see them. So it's quite a bit smaller over here. And I've also pre-set up this first problem. So this is our first problem here. We're taking this polynomial, our 3x to the 4th plus 4x cubed minus 32x squared minus 5x minus 20, and we're going to divide it by x plus 4. So we could set this up as our long division. This is the guy that goes inside the house. This guy goes outside. We could take our first term and our first term. We could absolutely do this one with long division. Long division is long, and this has a lot of pieces, and I don't want to. Ew. So what we do is we take our polynomial in standard form, and we write down just the coefficients, just the numbers. No letters, just numbers. But I can't skip any letters. So we're starting with our 3x to the 4th, and we're going to write down our 3. Then we do our 4x cubed, and we have our 4. We have our minus 32x squared, so minus 32, that's going to be our next one. Minus 5x, minus 5, minus 20, minus 20. And we didn't skip anybody. We had our x to the 4ths, x cubes, x squareds, x's, and then our numbers. So we just write down those numbers. So these would be these guys become these guys. These are our coefficients here. Then we need our root, our factor, our 0 for this guy. So we need to know when our x plus 4 actually does equal 0. Well, if we subtract 4 on both sides, that's going to give us x equals minus 4, right? That is where this piece comes in. There's this little box off to the side. And that is where we're going to put that minus 4. So we put all of our coefficients right here, and we put our root in the box. So coefficients and the root. Thus far, we have no letters over here, and that's going to be true. So that's what our first step is. We write our polynomial in our standard form using the coefficients. So 3, 4, minus 32, minus 5, and minus 20. In the corner, in our box over here, we put our root. So to do our steps of synthetic division here, what we're going to do is the first term drops. That's what this arrow is showing us. So the first term drops, so I'm going to put my 3 down here. I take the bottom times the box and put it under. So we're going to take 3 times the minus 4, and that's going to be underneath. So that 3 times minus 4 gives us minus 12. Then when it comes time to drop it again here, we add. That is the big difference between our synthetic division and our long division, is instead of subtracting, we add, which makes it a lot easier to keep track of signs. We're not going to have near so many double negative things as we did in our long division. So we're going to have our 4 plus that negative 12, which is going to give us negative 8. Then we're going to do it again. We're going to take our bottom times the left and put it under. So we have our negative 4 times our negative 8. So negative 4 times our negative 8, and that's going to give us a positive 32. So we put a positive 32 under here. So we took the bottom times the left, and we put it under. And then again, drop it down, so we're going to add. So I'm going to add. And then so we have our negative 32 plus 32, and that's going to give us 0. So then we're going to have the bottom times the box, and we put it under, so 0 times negative 4, and we get 0. And then we're going to add. Negative 5 plus 0 is negative 5. And then one more time, we've got our bottom times the left, and we put it under. So we're going to have our bottom times the box, and we put it under. So negative 5 times negative 4, we get a positive 20. Negative 20 plus 20, and we get a 0. This farthest right-hand piece is our remainder. So just like with our long division, we could have the remainder. Oh, that is too close to the wall. I can't actually put that there. There we go. So just on long division, how we can have a remainder, we can in synthetic division as well. It's going to be really, really, really uncommon for us to get something other than 0. It can happen, but it should be rare. When we're looking at all this kind of chaos underneath over here, what these are the coefficients of what would be on the top of our long division. So we could take our polynomial up here. If I divided it by this guy, this would look really, really similar to what's on the top. We just got to figure out which letter goes with which piece. And what it is it always goes down 1 degree. So since this was a degree 4, I know that this is going to be degree 3, so that's going to have an x cubed. That means this piece is going to be down a degree, so we're going to have our x squared that goes with the 8. This is down a degree, so we have an x here, and then this is our just the number. So to write our result here, we are going to have our 3, let's see, I'll switch the colors, 3 with the x cubed. Then we're going to have our minus 8 with the x squared. We've got plus 0x, which you can write if you want to, but we really don't need to. Minus 5. You could put plus 0x, or you can just skip it. Because what we're trying to see here is that if I take my 3x cubed minus 8x squared minus 5, and I multiply it by that x plus 4, we would get exactly back to what we had here. It would take us all the way back to the beginning. So that whole polynomial, there we go. I will turn the Roomba on in a little bit, but it's just so loud with the vacuum. Okay, so this polynomial are 3x to the 4th plus our 4x cubed minus 32x squared minus 5x minus 20 is the same thing as the 3x cubed minus 8x squared minus 5 times x plus 4. Okay. Questions on this one? Okay. Just making sure we're getting everything marked. I'm seeing everybody pop in. I'm just also trying to make sure I don't go over on my time because they are not giving us any bells today. So give me 1 second. Where did I put schedule? Oh my goodness. Okay, 28. Cool, cool, cool. I want to do another one just so we can see it. If you guys have questions on stuff, you can always toss them in the chat, or you can unmute if you want to. I know it's kind of weird. Okay, so the next one's not going to have the little list up on the top. We're going to practice it anyway. And again, I will get you a printout of that kind of checklist of what we're going to do for tomorrow. So here's our next one. We've got x cubed minus 6x squared plus 10x minus 3, and we're dividing it by x minus 3. So the first thing we're going to do is we're going to take all of our coefficients for all of our terms and line them up. So we need the numbers that are in front. So it's really, really important that this is in standard form, so it's a good idea to double check that it is. My biggest exponent is 3, and then 2, and then 1, and then a number, so we're good to go. So I need the numbers in front. So I need the number in front of x cubed. That's going to be a 1. I need the number in front of my x squared, which is a minus 6. I need the number in front of my x, which is a 10. And I need the number that's in front of the number here, or that is the number here, so we have our minus 3. So that's what I mean when we line up the coefficients. There's no letters in there, just numbers. So then we also need to figure out what we're dividing by. We need our root, our factor, our 0. So we're going to take that x minus 3, and we need to figure out what solution that's going to be. So we're going to figure out when x minus 3 equals 0, I need that root, that solution, that 0. So if we add 3 to both sides, we're looking for the place where x equals 3, because we add 3 to both sides. What that tells me is in this little kind of box thing over here, that's where we're putting the 3. That's how we figure out what piece goes in the box. We're going to put a big old line underneath this. And that's our setup. That's how we build this. That's how we start this. So then we're going to drop it, multiply, and put it under. On this first term, since there's nothing to go underneath, it just straight up falls. So our 1's going to be down here. We take the bottom times the left and we put it under. So multiply. 1 times 3, and it's going to go under. That gives me 3. And then we're combining down, so we're going to add these guys together. So negative 6 plus 3 gives me negative 3. We're adding. So that's first cycle. So remember how long that first cycle of long division was? These are significantly shorter. So now we're going to take our second cycle. So we take the bottom times the left and we put it under. So we have our negative 3 times our 3. Negative 3 times 3 is negative 9. And then we combine it. So we're going to add these two together. Negative 10 plus negative 9 gives us 1. Then we're going to take the bottom times the left and put it under. 1 times 3 gives me 3. We're going to add those together. Negative 3 plus 3 gives me 0. Again, more often than not, we should wind up with a 0 in that last spot. I always kind of box off this last spot to help us remember that this is the remainder. If you do not do that, that's totally fine. Just remember that everything goes down 1 degree here. So this, since we had an x cubed originally, this piece down here is going to be x squared. There we go. Got one more person coming in. Love it. All right. And then this one's going to be down a degree again. So this was x squared. Now this is going to be an x. And then this is going to be less than an x, so it's going to be just the number. So writing our leftover piece here, we have our 1x squared, -3 or minus 3x, and then we have a positive 1, so we're going to have a plus 1. So this piece, if we multiplied it times this guy right here, times that x minus 3, we would get back our original function, that x cubed minus 6x squared plus 10x minus 3. We get right back to the original thing. And if you ever want to double check and see if you've done it right, that's a great way to do this. Multiply these back out, we should get exactly here, exactly to what we started with. Okay? Questions on these two? Can't wait for my headset to charge so I don't have to do the flappy thing and I can leave my Roomba running, but I didn't charge my headset because we haven't used it in like a year. eLearning is so much fun. Love it. Okay, any questions on these two as they stand right now? We will continue to work with these tomorrow. I want to put up here because there is a typo on one of the 4.4 homework, so if you're starting on the homework, I need you to change question 3A. It has the wrong divisor, the wrong thing we're dividing by. So change question 3, the first one, to be dividing by x plus 1 instead of x minus 4. It does not work well with the x minus 4. So I wanted to give you guys that, and I want to make sure you have time to write it down. So we're not dividing by the x minus 4. We should be dividing by x plus 1. So tomorrow, again, we're going to keep working on synthetic division, and we'll talk about how we can decide when we want to do synthetic division, when we might want to do long division, and going from there. Okay? So work on stuff like that. Feel free to ask questions. If you're working on things today, feel free to send me Canvas messages, email in messages, or you can send me a direct message on Canvas or on Parent Square. There's a student version of the app called Student Square if you would like to not have the parent version. But that's what you're working on for the rest of the time, and you are technically in here for another 4 minutes. I have you marked down. I have everybody's attendance marked in here. So if you want to scoot a smidge early for the end of first period, don't forget to go to second period. That starts at 8:31, so you have 6 minutes to do that. But yeah, I'll get everybody's attendance marked, and that's kind of all I got for you today. So let me know if you guys have any questions, but that's kind of what we're doing.